Rightio. So that's who Homerton Sensei is. So Fazana and Harley. I'm just going to do register while everyone else just catches up with you. So I know you three helps. I know Dante's there. I know Warren's there as well. She was. Check your emails for me. Your resources are there. It's graph transforms, which nobody likes. So this is definitely one to be awake and alive for. Let me find the mouse as well behind. Boom. What new folder? Why is that even open? Ugh, graph transforms. You. So we've got Warren, Demetrios, Harley, Fazana, Omo, and Mawson, and brilliant. That's fine. I'll just mark in. I'm literally just marking the register while I'm getting everyone to. I'll say literally, I'm waiting for it to load up. It takes like 3 days to do anything. It's close teams with a bit. Actually, wait. Where's my mouse gone? Okay. Why does it take so long? That's still loading. Wow. All right, let's see what we've got. We've got a few. We've got Kais, brilliant. That's good. It's a while since I've seen you in a live chat on my YouTube. I did. That's good. Well, okay, cool. So if you've opened up your file, damn it, good to see. If you've opened up the file that I've sent you, you've realized you've ended up in graph sketching hell. All right. Before we go into that, before I give you some support on that, obviously we're going to. Was there anything from like the last few lessons that people weren't happy with that want to see like have some support with? Pop it into the conversation on the YouTube, okay? So drop it in the YouTube live chat. Don't drop it in any other playlists, all right? And then I'll talk about that and support that. Otherwise, I'm still going to give people about another minute or two to kind of migrate over here. Look at the graphs and transforms assessment that you've been sent, and tell me what you need to see there. Be aware this is quite a long one. So don't hesitate to ask for some help on it. It goes on to 2 pages and it's graphs and they take longer anyways. So why is it taking so long? You can vanish. You can vanish. So it's just like Candy's. It's not even my system, it's Candy's. Logging onto the Candy system is like unbearably slow. What have we got? Good if you didn't destroy my computer. So for someone saying no, you're comfortable with all the stuff. Well, that's really good actually. And to be fair, it's time to start praising the ones that have worked well. So right, I'm just going to pull up all our live chats and let's see who's worked hard and who I can say I'm really happy with. As it stands, well done, Harley. You've now caught up. You're still missing the Thursday though. The Thursday's work, so make sure that gets popped in if you haven't done that already. Dowit, everything's fine. Rashida's not even here. Bro, yours is late, but at least it got done, so fine. Try not to make me have to send those messages like no work for me. It's just a pain in my neck. Anyone know where Ziza is? Because he hasn't handed in anything yet. Good to see Jacob. Warren, your stuff's there. That's good. Kaisa, I have no work from you at all, and that needs to change up. So basically, the chats that I'm doing, those are your portfolios of work. If you don't have that work, it's going to affect your predicted grade straight up. All right? Ishmael, God knows. Rahat, God knows. Sabirul is missing 1. Jacob, everything's fine. Omo, perfect. Mawson, perfect. Olivia, perfect. Fazana, perfect. Demetrios, perfect. Kausa, perfect. Zeron perfect, Dante perfect, Jazir perfect. That's not bad actually. All right, so all you need to do, everything's apart from question 6. So was that question 6 on the last homework? On the last classwork? Let's have a look at that. So that's question 6 on trig. I'm just going to open up trig and have a look. So I remember, I think it was Dante say he was still working on that as well. I'm not saying he couldn't do it, but you know, it might be an idea. But, yeah, give someone a helping hand. Why not? And then we're going to do, or are you talking about this lesson's work? In which case I'm going to rate you optimistic, because this is not as easy as it looks by any stretch of the imagination. So yeah, which question 6 are you talking about, Warren? Help me out here. Talking about question 6 from last lesson or question 6 from this lesson. So what I'm asking everyone is have a look at this stuff I've sent you via email, which is the work. I'll send you a PowerPoint to go with it, but you know, watch in your own time. And tell me what you think will be difficult on there. Also, if you had problems from proof of this lesson. Okay, so let's do 6 together then. No harm in doing an example together at all. So let's do it. So it says sketch a graph of this guy. So you've got y equals, what I really need to do is have x plus 1 squared 2 minus x. So you've got, there's my hand, y equals x plus 1 squared 2 minus x. I'm just going to check if I've copied that out right. I think I have. That's what you've got. Oh, let's tidy the camera up a tiny bit. There we go. So it's all centered now. I'll move the cable again. That's a bit annoying. So, what can we tell from that straight away? Hopefully quite a lot. Because we know it's going to cut through the x-axis at positive 2. We know it's going to bounce off the x-axis at minus 1. How do I know bounce off? Because the power of the bracket there is even. So if it was 2, 4, 6, 8, 10, it's going to bounce off. All right? I know what the y-intercept is going to be. Yeah? I know the y-intercept will be, which 1 squared times 2 is 2. So this my x-intercept, that's my y-intercept. I also know the shape of the curve. I'm going to get an x squared out of this and a minus x out of that, and that's going to give me a minus x cubed. Yeah? So it's going to look like this. All right? That's a whole bunch of information I've got by just looking at the graph. In fact, that's all the information I need. Unless someone asks me for a turning point, and I don't think it's going to. All right? So is everyone happy with how I explained? Just by looking at it, I was able to get the x-intercept. It's what makes each bracket equal 0. How I got the y-intercept, I just took the number, raised it to the power, times it by that. And then I've got the shape. Minus x cubed goes down. If it was a positive x cubed, just to give you context, it would look like that. So it starts low, goes up. All right? So it's comfortable. So let's just quickly sketch that. It should take any time at all. It's going to go through, what is it? Go through minus 1. Going to bounce off there. It's going to go through, and remember you have to label the numbers. You've got to be a bit more organized than I've been there. I would think, I've said it's going to look like that. It's going to look like boom, boom, boom. So I'll put minus 1 there, and there's a clear 2 there. That's full marks. And it goes on, obviously. You've got to show it goes on forever. There you go. Graph done. No problem at all, right? No problem at all. Now, you've got choices here to do with the next one. It says, what does it say? Something about 2x, doesn't it? And you go, well, okay. F of 2x, hence. And I mean, what is f of 2x? If this is f of x, let's change that. Not that it actually makes any difference. Let's put f of x. Here's how I'd do it. I'd go f of 2x is this thing. 2x plus 1 squared 2 minus 2x. Yeah? So 2x plus 1 squared, 2 minus 2x. And that's how functions work, isn't it? Can you see all of that? No, you can't. So I better put it someplace where you can see it. Let's lose all of that. So f of 2x is 2x plus 1 squared, 2 minus 2x. That's how functions work. So if this is f of x, that's f of 2x. There are other ways of doing it. If it's inside the brackets, it means opposite. Yes, and this is y. If you're cutting the x-axis, yeah, that means y has to equal 0, yeah? So that means 0 equals x plus 1 squared 2 minus x. You comfy with that, yeah? So if you're cutting the x-axis, by definition, y equals 0, because any point on the x-axis, y equals 0, yeah? The height of any point on the x-axis is literally y equals 0, okay? Cool. So that means our equation has to equal 0 because the equation was y equals stuff, right? What's going to make this whole thing equal 0? You got something times something. Anything times anything, to make it 0, you have to make it one of the brackets 0. So what's going to make this bracket 0? 2 minus x equals 0, x equals positive 2. X plus 1 equals 0, x has to be minus 1. Yeah? And it's better to understand it is you have to make every bracket equal 0, because if you get a bracket like this, give an example. This isn't what we're doing. I suppose it was this. Okay, yeah, for sure you're just going to get this one, go, oh, that's x plus 1. What are you going to do here? The way you do it is you go, well, 2x plus 3 equals 0, x equals minus 3 halves, right? So think about it as turning brackets into 0, rather than think about it as, well, I'm going to just swap the signs, because it's not always swapping the signs, all right? So that's how that works. Cool. So let's move on to a little bit of what we've got here. And what I'm going to do for you guys now is just kind of say, well, let's do the analysis on this. Where's this going to cut the x-axis? This is going to cut the x-axis at minus 0.5, minus a half. This is going to cut the x-axis at positive 1. 1 squared is still 1, so and that's going to 2, so that's still going to go through 2. It's still going to have a bouncing off, that's going to bounce off there and go through there. So it's the same graph practically, yeah? Just a bit steeper, going through some slightly different points, all right? So that's how you can do the sketch pretty quickly by just understanding how functions work. So if I sketch that, where's it going through? It's still going through 2. It's going through 1 this time instead of going through, so it's going through minus a half rather than going through 1. And I said going through, I mean it's going to bounce off. And if you compared the two graphs, this one would be steeper, as in it goes up faster, it goes down faster than the f of x graph. All right? That's how I will deal with that sort of question. Now, the GCSE way you were taught was go, oh, 2x means that you're going to stretch it or pull it. I don't know what word they use for it. And that's, I suppose that's true. There's nothing wrong with that. But if you understand the maths of it, it's a lot easier to go, well, you know what? All I'm doing is replacing x with 2x. If I do that and use my graph kind of knowledge, I can just make it look like that. Yeah? And if they asked you to draw them on the same scale, obviously the other graph went through 1 and 2, so it'll be kind of flatter, less steep. All right? So I'm hoping that's making sense so far. If it's not, pop it up in the chat like I'm not. And then find the equation of the graph. And again, this is where my way is king. Because now they ask you to find the equation of that graph. All right? What you're going to do, just expand that. Yeah? Just expand that. And I know that's a pain in the neck. But to be fair, it's a pain in the neck that you can handle pretty easily, right? So I hope that makes sense to you guys. I hope that does make sense to you guys. That if you're doing f of x and then you got f of 2 of x, yeah, there's those rules that they make you learn at GCSE. But if you're lucky enough to know what the equation is, just substitute what f of it is into the f of x, and then just do your graph analysis from there. All right. Anything else there that's bugging anyone? No problem. So have a quick look. If you think you can take this on, you're free to go, with the caveat that you've got, there's a lot of work there, so I don't really want to hold you too long. If there's more stuff you want to see, stay in the chat, because I'm going to hang around for a bit, obviously. So if you need anything else, ask for it. You don't know about 7? Let's have a look. Let's have a look. All right, so just a quick reminder for 7. And the reason I say quick reminder, I'm sure you know these already, but I'm just going to give you the baseline graphs one more time. Because a lot of this stuff with graphs is, if you know what the original graphs are, you're okay. All right? And you can just make it from there. And they've got minus 360 to 360 because they're evil. Fine, we'll do that. That's not a problem. So sine starts at 0. And if you remember that, sine starts at 0 and goes up. So that's sine. Put them a little too close together. Never mind. I thought I'd get away with that, but don't. Here's your cos. Cos starts at 1, so it's symmetrical, isn't it? Goes up like that, 360. So this is what your graphs look like between 0 and 360. It's a W shape. And then tan x is annoying, but we'll do it anyways. Can you even see the tan x halfway down there? Yeah, just that. It repeats every 180, so you're going to get this. Oh, for flip's sake. I hate graph sketching. If somebody sets me a question on trig, though, I will draw them just to get started. For every single time, I'd start by drawing the graph as it is without kind of, before it's remixed. Put it that way. Oh, God, drawing them backwards is horrible. So where are we at with this? That's 90. That's 270. I have to do one more. Okay. So that stops at 360. And that's where it hits 0. Okay, so that's negative 360 to 360 of tan x. So those are the graphs we need to be. I'm going to leave them on there for a minute in case anyone didn't know them. Just a reminder of how they work. And remember, every 90 degrees something happens. All right? Cool. So what I'm going to do is do an example of 7 now. Let's do... What's the hardest one? None of them are particularly bad, actually. All right, I'll do the first one. Because I think actually out of all of them, that's probably is the worst one. They're all equally bad, but Right, cool. Leave those graphs on there for a few more seconds. Then I'm going to do 7, the first one. Right, let's roll. Okay, let's do this. So what we've got here is cos a half x. So true to what I said, I'm just going to quickly sketch again cos x. It looks like this. All right? It looks like that. Can you see that? Let's find out. Yeah, you can. Beautiful. If you've got half x, that's slowing you down. Yeah? So basically, what used to happen at 90 degrees now happens at 45 degrees. Yeah? So right now, but this is between minus 360 x to 360. All right. So if I substitute, say, 360 in there, a half of 360 is 180. So basically, the graph is getting cut to stop here and stop there. So minus 360 divided by half is minus 180. And 360 times a half is 180. So I'm basically going to cut the graph there and there. We're not going to see any more of the graph other than that. So what will my graph shape look like? It's going to go through 1. It's going to go through, and stop halfway there. It's going to drop down, and it's going to go through. When are these bottom points going to happen? At 360 and minus 360. All right? Because minus 360 times by half would give me what I'd normally get by minus 180, and vice versa for this. So when is it going to cut here? When's that going to be 0? Well, normally it's 0 at 90 degrees. But you've got a half x here. So you need to put in 180 degrees to make it 0. So there's 180. There's 180. Am I finished? Yes, I am. Because there's no other point that's important, is there? You've got all the x-intercepts. You've got all the y-intercepts. You've got the 2 bounds of the graph. That's all there is to it. So it starts by drawing the graph and realizing what is that transformation doing to x. It's basically saying that whatever you're putting in, you're only going to get half the value for. So therefore, if I draw my normal cos graph, the whole thing, I wouldn't get all of that. I'm only going to get half of it, right? So I draw big lines, go, okay, I'm only going to get up from here to there. That's it, from here to there, nothing more, all right? So I draw that as just a sketch without inputting any numbers on it. I know that the endpoints are minus 360 and plus 360 because that's the range I've got. Then there's only 3 points I need to. It's obviously still going to go through 1 at 0 because half of 0 is still 0. And it's these 2 guys that matter. All right, fine. When does it cut through the x-axis? At 90 and minus 90. Okay, cool. What's a half x equals 90? That means that, excuse me, it's 180. It's 180, 180. All right? And that's that. That's literally all there is to it. Now, some of the other ones, you've got transformations where you're multiplying by -3, for example. If you're multiplying the whole thing by -3, all you're doing is times in a y coordinate by -3. So it's the same graph, but flipped upside down and stretched by 3. Tan of -x, if I'm looking at that one, just think about it. Everything that was x is now -x. I think and sine x plus 30 just means you're moving the graph to the left 30. All right. I'm hoping that's not too bad, but if there's any of them you still think, now I want to see that example done for 7. You've done 7-1, I'd like to see 7 something else. Again, just ask for it. So I'm going to hang around here for a little longer. All right, so I hope that makes sense. Pop in the chat box if you want to see something else done from 7, or whether you just think, that's an adequate example. 7-2, fine. Brilliant. Oh, your Wi-Fi is quite good, Usually there's some proper lag on these things, but yours is on point. All right, cool. 7-2. Yeah. 7-2, 7-2, 7-2. Okay, -3. Okay, beautiful. So again, you got y equals -3 cos x. Let me just see if that's in visible range. Yeah, it is. Okay, cool. So first of all, you just start with y equals cos x again. Yeah? Sounds boring and stupid because obviously you know what cos looks like, but you know what? Doesn't do any harm, does it? Yeah? All right, take care, Warren. Good stuff. I'll see you around. Make sure you pop your stuff back in there. Anyone who has forgotten, there's still Dr. Frost work as well. Have a look at that as well for me. Right, cool. So what's going to be the effect? We're timesing every coordinate by 3. Yeah? Why is that? Because you're timesing by 3 is going to make everything 3 times bigger. All right? And the effect of minus in it makes everything that was plus minus and everything that was minus plus. So just by thinking about that, I know I'm still going to go through the same coordinates, but every y coordinate is going to be times by 3 and turned upside down. It's going to go through here. Yeah? It's going to go through there. It's going to climb up to, it's still go through there. And it's going to climb back down to here. How far did you get here? You just get a U-shape. So here you go. You're going to get this. Yeah? So that should have gone through the points of Ben. Forget about the x's. Let's just keep the line. Yeah? So what do I know about this? Instead of this being -1 here, it's going to be +3. So this -1 here has now become this +3 here. So this has become that. Outcomes, I times it by 3, but it's a -3. A -1 times a -3 is a +3. This point here, see this guy here, that's 1. 1 times -3 is -3. So this guy here is -3. Same thing with this guy. He was +1 as well. +1 times -3, still -3. So what you're seeing is I'm looking at the key coordinates, right? And I know it's symmetrical, so that is not symmetrical. Bloody hell. That same height will be nice, my dude. Right, there we go. This is why I hate drawing, because I cannot do it. So think about this point here, yeah? All of these points on the x-axis, your y-coordinate is 0, yeah? Times in 0 by -3 don't do nothing. That's why they're all in the same place, all right? They're all in the same place, no problem there. This guy here is -1. -1 times -3 is +3, yeah? So this, which is normally happening at 180, so -180 here, is normally -1, is now +3. This guy here, this was +1 in the original graph. +1 times by -3, well, that's -3 again. The only thing I need to add to this graph are the key points, yeah? So all of the x-coordinate are not going to change. It's because the number's on the outside, the y-coordinate's the one that changes, all right? I hope that makes that a little bit clearer. But again, draw your original graph first and just figure out what the hell's happening here. So here you got y equals 3 cos x. That means the cos x is untouched. But then you times it by 3 and then you times it by minus, and that's what makes the change. Yeah? So you start with the cos x. And okay, what does the effect of times in -3 do to it? It means you're going to times every single y coordinate. Because remember, y is cos x, yeah? And if you say y equals -3 cos x, beautiful. All right, cool. Anything else from anyone else? For us, I'm going to vanish. We did quite a lot today. We did Kahoot and we did this. So I'm pretty happy. Make sure the work gets sent in. Make sure we are looking at our Dr. Frost. Let's get this. Don't have to send message every day saying, your work is not in. I have to chase you around. All right, cool. I'm going to do register as well now. I'll hang around doing register. If anyone wants anything else, just drop it in the chat. If you need to go, by all means go, because to be fair, I'm done here in terms of content. There's nothing new or exciting going to happen now unless people want a question to be answered. Kausa today. Kausa, if you're alive, put your name on the live stream before I kind of you. Yeah, Demetrius, you take care. Who have I not seen? I ain't seen Kausa. I ain't seen... Who else have I not seen? I've seen all of you guys. Anyone's on the chat. If Fazana, yep, I've definitely seen you. Where's the Dr. Frost? He sent it to your email, my dude. If you didn't get that email, can you pop on the live chat? So pop that on the live chat so I can send it to you. I sent you the Dr. Frost PowerPoint to go with this, and I sent you the worksheet. So I know this one's super hard. I mean, it's not really, but until you get to it, it gets kind of awkward. I hate this computer so much. Okay, what are you even doing now? All you gotta do is let me type in the password. Thank you. That's all right, cool. Has anyone popped anything on the chat? Oh, you found it now. Yeah, beautiful, beautiful, beautiful. Yeah. Is this due by next lesson? Technically, it's due by the end of today, right? So try to kind of stick to that. It should be done by the end of today. This one is a long one, all right? I get that. But, you know, if you can finish it by today, the worst case scenario gets finished by tomorrow. I'm taking records of ones who aren't doing it. I'm going to have to start doing text message showing for people like Rahat and these kind of people that haven't showed up or whatever. Are there questions on the PowerPoint? Yeah, there'll be examples. I'm not expecting you to do the examples. Obviously, the examples are there. The only work you need to hand in is the worksheet. If there's like, are there kind of things to help you learn? Yeah, there are on that PowerPoint, obviously. What am I doing? I'm doing register. Boom, 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 boom. Come on. What are you planning to take? Don't know. This is literally, if you're done, I mean, it's like, if you don't need anything from me, just go, because literally all you're going to hear is me shouting at the computer. Not really computer's bloody candy. Even now, when there's no one in there, which have a system that lands. That's legendary. All right, cool. Oh, for flip's sake. Anyone who hasn't popped their name in his chat, but is here, I don't really care if you put your name anywhere else. This is the only thing I check is the live chat. Can you make sure that you put your name in the chat before I do the register? Which I'm literally doing now, if it lets me. Go out of the way. I'm going to do a casting thing as well. I'll tell you what, I'm going to shut this one down. I don't think anyone's going to pop up with the... Oh, good.